to today's GVU Brown Bag Talk. Let me make the usual administrative announcements before I introduce today's speaker. So first off, if you have devices that buzz or ring or vibrate, now might be a good time to turn them off. Second, please be sure to pick up and throw away all your trash before you leave this room. And third, if you're taking the course associated with the brown bag, please be sure to sign the sign-up sheet, which is over here on this other podium. Quick plug for next week's brown bag speaker. We will have Kevin Delsberger as our speaker. Dr. Delsberger is an MD and a PhD. He's the Vice President and Chief Medical Officer at Georgia Regents Health System. And he'll be talking about patient health and hospital quality in the era of big data. Today, though, Okay. Today, though, I'm very pleased to introduce Martin Eppler as our speaker. I think many of you have already met Martin. Martin's here as a visiting professor from the University of St. Gallen in Switzerland, where he is chair of communications management there. And he'll be spending this semester with us until April. So he'll be telling us about some of the work he's doing. Let's welcome Martin.
Thank you, Keith. Thank you very much, Keith, and thank you for coming and for your interest in this unusual topic today. Can you really visualize knowledge? Can you really make visible what people have in their heads? That's what I'd like to talk about in these 50 minutes, and it's wonderful to be here at Georgia Tech. So many brilliant people, especially in the areas that are needed to make knowledge visualization a reality, namely cognitive science, cognitive systems, of course, information visualization, but also communication, especially computer-mediated communication. And so I'd like to share some of the research with you that we've done in this area, but also introduce you to this new and exciting field of not just research, but also practice, because this is something that is impacting the way, as it should, impacting the way that people are running meetings, holding workshops. But still, what we see happening a lot in the corporate world is they run meetings like 20 years ago, and many times that is not productive. And so we've examined how to make meetings more productive through the use of computer technology, and more specifically, collaborative visualization. So just to give you a sort of a heads up, what are we going to talk about? Collaborative knowledge visualization in action. We've always been doing that, even 20,000 before BC in the caves of France, where cavemen tried to explain how to go about hunting. They visualized it as paintings. Of course, from the blackboards at school that this is something that can be used to convey knowledge, constructing insights. And then, of course, in the business sector, we've been using flip charts for a while, like this one, to sketch out our ideas and make them clearer in this manner. But then something interesting happened, and technology kicked in, the slide projectors, and things became very polished, and things became less interactive than they were before, right? And now we're at the, I think, beginning of a new era where things are becoming interactive again, where you have large touch screens, like, for example, the Microsoft Surface Hub that was just announced about 2 weeks ago. You have large interactive power walls, as they are called, where people can engage with large sets of data and also make their insights visual to others. And so here's what knowledge visualization looks like. It's more than just visualizing big data and interacting with it. It's also taking into account people's experiences, insights, and knowledge. So it can be, tabletop mounted touch screen, as you can see here on the left. This is actually at the ETH Zurich, where we're using the Visualization Value Lab. Or what you see here in the middle is actually Procter & Gamble's Decision Room in New York, where they interactively dig deeper into data or torture data till it speaks to them about the relevant market insights, but do so in a very collaborative manner. Or here you can see a power wall where people jointly analyze data in what they call visual discovery, or typical workshop settings where people in an ad hoc manner visualize the way they want to talk about issues, the projects that are currently going on, much like in a Scrum board that you know from software development. Or here another picture where you see people collaborating on an interactive whiteboard, right? So this is the kind of things I'd like to talk about. What makes these settings effective? What can we learn from research, and what can we learn from theory about how to visualize what you have in your head in a team setting? Now, our take on this label, we're not the only ones using the label in my research group. Our take is that knowledge visualization designates really any kind of collaborative practice that uses flexible or fluid interactive graphic formats in order to facilitate knowledge creation, knowledge sharing. Most interestingly, I think, the integration of knowledge among different professionals, and also to use that knowledge effectively for, in our case, decision making, planning, or ideation, creativity. And any form here, that means really these formats, they can range from, simple sketching, right? So we also examine that. It can be even physical, tangible visualization, and new forms. We've done a number of experiments on, for example, knowledge visualization in Second Life, in other formats. So it's a whole spectrum of visualization formats that we can use if we want to make our knowledge more accessible to others and integrate what we know. And knowledge visualization, as you may know, has other connotations. Sometimes scientific visualization or bibliometric visualization is also referred to as knowledge visualization. But in our context, it's really the use of interactive visualization technology to improve the quality of meetings, workshops, whether virtual or real. And I want to tell you a little bit about our experience from the last 10 years of how to make that happen. I want to first talk a little bit about why you should care about this topic, the benefits that can be sort of reaped from knowledge visualizations, the kind of problems that this new field is aiming to solve. And then I want to share 3 key concepts from this domain with you, 3 seminal sort of constructs from this field that I think are very useful for anyone doing visualization research or practice. And then I want to add a 4th one that we have found through our experiments that we've done globally in India, in Singapore, in China, in Finland, in the US, in Switzerland, in Germany, and in Italy. Because there's also a cultural component to, of course, meetings. And I'm going to show you 2 experimental results and a new concept that we have derived from this series of experiments. And then I also want to show you how this can be used in real life, sort of the tools that can ensue from that kind of research, some new methods, some new techniques, some tools that you can use Monday morning to maybe have more productive meetings yourself in your research group or in a student team. And I'll wrap it up with a few conclusions, and then I'm very much looking forward to your critical questions and our discussion. So let me start by talking a little bit about the premise behind this field of knowledge visualization. What are the problems we're trying to solve, and which benefits have we been able to observe that you can have when you visualize what you have in your head instead of just talking about it? And not just using, like I'm doing right now, a slide, but actually something much more fluid and interactive and collaborative that lets people sort of input immediately what they know to a conversation. So the problems that we're trying to solve have been around for quite a while. They're essentially communication problems, right? And this is where I think this field also differs from information visualization, where you have a different kind of challenge that you're trying to address. How to, for example, deal with masses and masses of data. This can also be a challenge here, but it's much more communication oriented. For example, one of the key problems that we have in meetings, and this is probably one of the most researched communication challenges of teams, is the common knowledge effect. It sounds really weird, but it has been researched extensively by Stasser and others, and it's the following problem, that whenever people meet to share information, they tell each other exactly that which they already know. When people gather together to have an information exchange, they tend to focus on the things that they know others already know. So basically, they're wasting time. Now, why would they do that? Why would they focus on common knowledge instead of sharing what they know exclusively? Well, one reason is it's just so much easier, because you get nods much quicker when you say something that everybody already knows, right? You get common ground. You get confirmation. Whereas if you introduce something new into a discussion, people, might shake their heads, might look at you in a puzzled way, and it might, stir some controversy or discussion. So that we have a natural tendency, unfortunately, to tell others what they already know. And of course, this is bad for decision making. And so knowledge visualization really tries to nudge people to share what they know exclusively, the insights that they have that others may not have. Right? And it's also called the hidden profile problem because you cannot look inside somebody else's head. Their knowledge profile is hidden to you, so you often cannot activate it. However, with knowledge visualization, I will show you, we can reduce that problem quite a bit. A second problem that I've researched extensively myself is information overload. That in a lot of contexts where experts are meeting with decision makers, let's take engineers who inform managers about the new possibilities of a technology, they overload them, right? They provide too much information and can no longer be integrated into the manager's mental models. And managers are really bad at saying, I didn't get it. They have a great incompetence compensation competence, right? To sort of hide that they haven't understood something. And so often you have bad decisions because managers were overloaded by engineers, by lawyers, by other experts, and they didn't find the insights that were important. The experts weren't able to connect the different insights appropriately. Or a third well-known problem with team meetings is groupthink, that the group follows the opinion of the strongest member, of the, let's say, the boss. Whatever the boss thinks, they agree with, right? Instead of looking at the evidence, instead of looking at experience from others, they just follow the lead of whoever's in charge, right? And you have a sort of pseudo-consensus where people believe, oh, we all agree, but that is just because the people who didn't agree didn't speak up, right? And so it would be great to have a tool that lets you visualize the different opinions that are in the room and then make a better decision. And a last problem that Stanford Business School professors Pfeffer and Sutton have researched, and that is quite omnipresent as well, is the knowing-doing gap. That you have a lot of knowledge in the room, but you're not using it, right? People hide behind smart talk. They have no incentive to share their knowledge because it may become disassociated from them. People are promoted not based on the knowledge they apply, but just on sounding smart, right? There's all these sort of inertia effects with knowledge if you don't integrate it and if you don't put it into a decision context. So a lot of time what this boils down to is, in meetings we have a lot of knowledge in the room that, however, is not optimally used. So why not use the technology we have available? Why not use visualization as a way to integrate that knowledge and make better decisions? That's the premise of the knowledge visualization field. And as you may know, there are many, many studies that show that visualization has numerous benefits. In information visualization, we usually focus on the cognitive benefits, like visuals get more attention. We've done a number of studies to show that they increase recall of information. They help have a better understanding, they help in elaboration of material, and very importantly, can lead to new insights. You discover new patterns when you visualize information in an adequate manner. But interestingly, for the field of knowledge visualization, there are a few other advantages that we can really use from the power of pictures, and they are social and also emotional. Visualizations help to coordinate people better. We can have better fights with the help of visualization. We've done a number of experiments using real-life managers where we've been able to show that the moment that somebody visualizes some of his knowledge, people can have a more productive conflict, because when they disagree, they're not attacking that other person, they're just referring to something he drew with software or without on the board or on a flip chart. And that changes the dynamics of a discussion. So visualization has a lot of, let's call them interactive or social advantages. One of them being it turns unproductive conflict into a productive conflict. It changes from interpersonal conflict to a topic-oriented conflict, simply because of the fact that you can criticize what's written or visualized on the board, and you don't have to directly attack the person that you disagree with, right? And also, and I've seen this happening with a lot of executives, that usually make eminence-based decisions or eloquence-based decisions, but not evidence-based decisions, that when they see evidence in an attractive, simple visual format that they can interact with, they give it more weight, right? They're motivated to really, they're mobilized to interact with the evidence, right? If they can annotate it, if they can work with it. Right? And so that gives you a few of the advantages that you can achieve with visualization, and we summarize them in the CARMEN acronym, but like Carmen in Bizet's opera of the same name, it's beautiful, but it's also risky. Of course, there's a few side effects with visualization. For example, the illusion of understanding. I've done a number of studies where we've been able to show that when you visualize what people think, sometimes they overestimate their level of understanding, right? Which doesn't happen when you read a complicated text. You realize you didn't get it. But with visuals, they can be deceiving, and so we summarize also the disadvantages in an acronym called COMA. You can put people in a coma with visualization. You can create confusion if you overload a visual, right? Confusion through overload. You can manipulate people by misrepresenting their insights visually. And another big problem in visualization is ambiguity, right? An arrow like the one I just drew can mean many things. It can mean A leads to B. It can be A precedes B. It can mean A will eventually lead to B. It can mean A has some sort of rights over B. An arrow could be very ambiguous and lead to misunderstanding. So basically, if you want to reap these benefits, you have to use visualization well. You have to pay attention to guidelines. You have to make the best use of it. So how can you make the best use of visualization? I want to share with you 3 key concepts that are highly cited in the visualization field, that is still a bit fragmented. And then I would like you to see some examples of how these 3 key concepts can be put into action. And the 3 key concepts that I'd like to share with you are representational guidance, cognitive free ride, and law encoding. And I think they're fundamental principles of how you must construct a knowledge visualization so that it can lead teams to new insights. The first one is, comes out of the field of computer-supported collaborative learning, CSCL, has been first proposed by Souters and others, and it basically tells you that when you are using a visualization, you should use it in a way that is conducive to the dialogue that you're having with your team members, right? That the visual has some properties that let you talk about one thing first and another thing later, right? And Souters, he calls this representational guidance, that a visual, if you want it or not, always provides certain affordances of how to talk about it. And I'll show you an example in a minute of what that means. Now, when you follow the visual through its representational guidance, ideally that leads to insights. And what Shimoshima, another diagram researcher, this is another field that it's important for knowledge visualization, diagram research, has found out is it depends how you design a visual, how you make certain constraints effective, what you make more salient. But great visualizations give you a free ride. They give you insights for free without any cognitive effort. You just look at it and say, aha, I got it, right? So ideally, a knowledge visualization, when you build it well and you're done, should give you something you didn't know before. And that's what in diagram theory we call a free ride, right? And thirdly, and this is a concept by Cheng, another diagram researcher, you can encode people's knowledge in the way you interact with a diagram. Great diagrams or visuals behave in a way that is consistent with how the problem plays out in real life. Now that's the theory. Let's look at this in a very practical example. Now, what you're seeing here is a very simple diagram, like a radar plot, that we're using to help project teams that are interdisciplinary, that are made up of a lot of professionals, have a better overview of what they're doing. So basically, we're bringing together the finance people, the IT people, the project managers, the marketing people, to sit around the table and say, hey, what situation are we facing? What is this project about? And so we take them through a process where first They think about the dimensions of their work. In a second step, the factors for each dimension. So they say, well, we'll have to talk about our resource situation, how much budget do we have, how much staff, how much time, and so forth. And then also the scope of our goals, of what we're trying to do. And then they also look at interdependencies. So how does one factor influence another? And they visualize that. I'll show you that in a demo in a second. And then they sort of parameterize it. They sort of say, well, do we have a lot of time? Are we overstaffed, understaffed? Is quality very important? Do we have to pay attention to compliance? So the way the diagram is built leads them through a productive dialogue. That is called representational guidance. That you construct a diagram in a manner that is conducive to good dialogue, to good conversation, from overview to detail, for example. From just a few dimensions, in this case, as you can see, there's 4 dimensions: difficulty in this project team, resources, tools, and scope, right? And then you add the factors, then you look at their dependencies, how one drives another, and then you sort of try to reach an agreement of the situation you're in. So that's the notion of representational guidance, that a diagram invites you to talk about certain things at a certain moment, right? And then if you want to use this, by the way, this is online at diagrams.org. So you first have a sort of a table that you fill in with the dimensions, and you can edit that. Then it asks you, it visualizes that as a radar plot. You can just enter positive or negative dependencies among things, and then you can play with it. You can say, okay, what would happen if we increase budget, right? And you could see, oh, if we decrease budget, our staff size would have to be reduced as well, right? Or what happens if we reduce the systems, or what happens if the risk increases, if turbulences in the external environment increase. What you see in the middle are the connections between these variables, because some people may know about one area of the project, like let's say finance, but neglect the impact of that on IT. And so with this they have and this is on a large touch screen where they can basically stand in front of it and move it around. And if they say, wait a minute, we forgot that this has an impact on this, they just move it together with their fingers. And the computer knows then that these two things are connected. And another team can work with these dependencies, right? But for that, they must construct it in a certain manner. They must, because it should respect the knowledge of all of them. And that is called representational guidance. When you do that, you get to a free ride. For example, here you can see at one glance that when they did that, they found a discrepancy. You can see that things on the left are much bigger than things on the right, which for this team meant, hey, given the difficulty and the scope of what we're asked to do, our resources are really not in place. We need to ask for a bigger budget. We need to have better tools, right? So you can see at one glance, and this is the free ride, this is not a symmetric shape. We have a problem. This project has too great a scope, too many demands, given its resource endowment, right? And when you have this one glance insight, that's what diagram researchers call a free ride, right? And it's what makes a great visualization great. That when you just work with it, you go through the process, ta-ta, there's an insight. It's yelling at you, hey, something's not right, right? It gives you sort of an instant insight, right? And there's certain techniques of how to make these insights appear, certain ways you can design that into a system. And finally, the third concept I want to share with you is by Cheng, and it's called law encoding. As you have seen before, when I move one of these things, those that are dependent from it move maybe in the same direction or in another direction. They may move quickly or slowly, right? Or only after a certain point, depending on how people's laws, people's knowledge about dependencies has been encoded in the diagram, right? And this is different from information visualization, where basically you just encode data. Here we're doing something different. If I go back, we're encoding people's knowledge. So you might have for example, if I go back to dependency, right? You may have somebody who says, hey, wait a minute, the more we increase time pressure, the less people will pay attention to documentation. So this is an inverse sort of relationship, right? And I've now made that law that the more you put people under pressure, they less document things. I've made that part of the diagram. So when I now, do you see that connection between, right? So time pressure is now connected to documentation, because some people said, hey, in my experience, whenever we had lots of time pressure, people just forgot about documenting their whatever code or what they were doing, which is something they know. And there's a risk with big data that we forget that big knowledge, that we forget these important insights. Whereas through this simple interface, people can tell the system that, and then when others are using the same tool, they will be made aware of it. So if I go back to the diagram and I increase time pressure, do you see what's happening? As time pressure is increased, documentation becomes minimal. And so we can talk about that. Of course, this does not have the level of accuracy that, I don't know, your Excel chart or any InfoVis application has, but it doesn't need to. It's just a trigger for conversation, for sense making, for knowledge integration, right? To have sort of a good discussion. And this is the concept of law encoding, that the diagram can capture people's laws, what they've experienced. Does that make sense? So for those of you who are interested in these three seminal concepts of visualization, just in the documentation that I will make available, I have a bit of more material. How Suters defines representational guidance, namely as the potential actions afforded by a representational notation, which may influence what is discussed, right? It constrains what might be expressed and makes certain constructive activities, ways in which the representational artifact could be extended, more salient than others, right? And that is done, like in most visualizations, through clever constraints. I could only increase or decrease the value, as you have seen before, and by making things more salient or less salient. For example, if I go back one more time, you can see that the budget variable has like a halo, right? It's more salient than the others, and it should be, because if you look at the connections, budget has the most connections to the other factors that influence this team's project work, right? So it should be more salient, because people should talk about that. If the budget has so many, influences so many other facets of the project, like the design, the documentation, the compliance, and what have you not, then maybe we should talk about it, and we should share knowledge from the finance side to the IT side about why the budget is where it is, and what we could do to change it. So salience just means making the things we should talk about more visually dominant, I guess you could say. So free ride, I just want to give you a simpler example. Free ride is a very influential concept in visualization studies in this emerging field called knowledge visualization. It's basically when the diagram conventions and constraints and operations are such that when you interact and sort of play with the diagram, some fact that you did not encode explicitly becomes apparent. It's really torturing the data, or in this case, torturing the knowledge till it speaks to you, right? For example, you see this Venn diagram here on the right-hand side. You can see, let's say the following. These are all my clients, and this is my product A, this is my product B, and this is my product C. You can see at one glance that the biggest chunk of our clients buy product A, right? That's the most popular product. You see that at one glance. That's a free ride, right? You can also see that, let's say the triangles are international clients, that there's a few international clients who buy product A, but only international clients buy product C, with the exception of one guy. And this guy's not even profitable. You can also see at one glance that, let's say color coding indicates profitability, that we're making money with our products A and B mostly, but with product C we're really having unprofitable customers. You get these instant insights by just looking at it. And that's what Shimoshima calls a free ride, because you don't have to exert a lot of cognitive effort to get these new insights. And I think that's really the holy grail of knowledge visualization. To design visuals that when people share their knowledge, they get new knowledge in return. They learn something they didn't know before. That comes, like in the example that I showed you before, hey, this project really does not have enough resources for what we're asked to do. Maybe they were not aware of that when they started. There are other labels for this influential concept. Some call it derivative meaning because you derive meaning from what is mapped. Some call it graphic inference because it's really an inferential process that you're supporting. And last but not least, the third concept I wanted to share with you, the one of LEDs, or law encoding diagrams, by Cheng. And he defines them as representational systems that capture the laws of a domain in the structure of a diagram, using geometrical, topological, and spatial constraints. I wouldn't just say in the structure, I would also say in the behavior. If you remember what I did before, when you sort of pull at one side of the diagram, something in the other side also happens. So it can also be the behavior of the dynagram, because it's a dynamic diagram. And that in a way that each instantiation of a diagram is a single case of the laws or an example of the phenomena of the domain. The example I showed you was from project management. Right? So these are three existing sort of pillars of this domain. Representational guidance, you should make diagrams so that they support conversations people have in meetings. Free ride, that should lead to new insights. And law encoding, you should be able to offload your knowledge into the behavior and the sort of structure of the diagram. And we found a new concept that I'd like to share with you that I think has ramifications not just for the way we hold meetings, but for a lot other areas. And I want to show you two experimental findings and then derive from that our concept. So we've done a number of experiments over the last couple of years, and what's peculiar about our experiments, we use real managers. We don't use students, we just use managers with at least 5 to 10 years experience. Because we believe we get more external validity like that. We can generalize better to the future users of these applications. So in this study, we used 264 active, experienced managers, and we gave them a task to solve. This was not electronic, this was just on paper. And we discovered something really interesting. We gave them charts, and they had to do an analysis of which project gives the most payback. It was about different cost reduction initiatives. And the only thing that we changed is, for half of them, we laminated the charts that we gave to them. And for the others, we just gave them on a simple piece of paper and gave them a few pencils and said, hey, feel free to scribble on it if you want to. And here's the really interesting finding. Those groups, we always put them in teams of 2, right? And we randomized them. Those teams that sketched on the bar charts were significantly better at making the right call, at finding the most effective cost reduction strategy. Although it was just about calculating. And this was interesting that we thought, well, this makes no sense, because in InfoVis, it doesn't really matter whether you can scribble on a graphic or not. What matters is the quality of the graphic. But it turns out that does matter, and there's some good theory, like activity theory, that explains why when you interact with something in a very direct way, like scribbling on it, circling, connecting things, that makes you a more accurate decision maker. Because you're substituting something abstract, calculating, through something very concrete, scribbling. So this was the first sort of wake-up call for us, and we saw, hey, look at this. Those that, what we call sketch mark on the data, on the bar charts, that scribble on it, were significantly better at finding the correct solution, avoided the worst solution a lot more, and were also, but this was not significant, sometimes less distracted from the anecdotal evidence we gave to throw them off, right? So there's something about sketching that hasn't been accounted for in earlier research. And just a couple of weeks ago, we did a second experiment. We said, okay, that was about decision making. Now let's take another very important management task, coming up with solutions. So in an executive MBA, we asked them to do a virtual ideation session. They logged on to Adobe Connect, which is just a virtual team room, and always were paired up. We paired them up randomly. They didn't know with whom they were working. And in this Adobe Connect room, they basically could place their ideas. One person had orange, the other blue, and they could just, do brain writing, basically. And the question we asked them was, how can we improve the quality of our MBA program without affecting its cost? Now, this was a controlled experiment. So we had basically 4 different conditions. What we manipulated was the interface of the software. For some of them, we made it look very sketchy. And for the others, we made it look like PowerPoint, very polished bullet point. And you would think such a minor change does not have any impact on people's creativity. But you have to think again. Because here's what we found out. So the only thing we changed was, you can see that very clearly here, the style of the icon that was next to every idea that they would place. They were collaborating virtually, no talking, just ideating on Adobe Connect. And then we crunched the numbers, we analyzed, right? And don't be scared of what you're seeing, let me just guide you through. The most important finding is this one, on the top left-hand corner. Those teams that worked with sketchy bullet points pushed themselves harder to improve their ideas. They iterated a lot more than those that had a polished bullet point. You can see that. Mean number of elaboration, higher, right? You can see that here. This figure here, it's higher than the one below. The mean number of building on each other's ideas was much higher in the sketchy groups than in the polished one. Also, you can see the mean number of elaborations per set, per idea set, was higher, although not significant. And then, even more interesting, actually, elaboration matters, that you build on each other's ideas. Those groups that build on each other, where person A and person B didn't just write down ideas in isolation, but they actually looked what the other guy had posted and built on that, their ideas were much more feasible. We had independent coders analyze the ideas, and we found a correlation between building on each other's ideas and making them more feasible, which is not surprising, right? But it makes the case that this is important. What we also found, this is another part here in the data, the good idea proportion was higher in the groups with the sketchy bullet points than those in the polished bullet points. So what do these numbers tell us? Make it ugly. Make it ugly. If you give somebody a visualization tool that lets them express their knowledge, their ideas in a very polished manner, it creates like a museum effect. People go, oh, that's so nice, I'm not going to touch that. If you want, however, that people build on each other, that they're more creative, that they push their decision-making, their solutions, you should make the visual style, and not the font, the visual style of the icon, of the whole setting, look provisional. We call that, it should have low perceived finishedness. Yes?
Can you go back a slide for a second?
Yep.
So in that top left box, the only thing you changed with the 2 experiments was the icon next to the text line.
Correct. We also checked for font.
Okay.
But that did not lead to a significant difference.
But everything else about the UI was the same.
Everything else about the UI was the same. The color, everything was, the only thing we changed was one icon looked sketchy, because we thought, why is sketching so important? Why is that look of provisionality, what is that doing to people? It makes them pay more attention. It makes them see that this is just a proposal, we can work on this, I can make it better. But when you reify it too much, when you make it look as a thing, their propensity to build on it is significantly reduced. And I think that's something you should take into consideration when, for example, you design software. Make it look sketchy. People will work harder, right? They will be less afraid to criticize each other and build on each other's ideas. And that's what we've been able to show with this study, and it matters. Those that worked in the sketchy interface had higher creativity, had ideas that were more feasible, and had a higher good idea proportion. Yes?
Did they also take longer to finish this task?
No, exactly the same.
It was a fixed time.
10 minutes. 10 minutes. We clocked them, 10 minutes for all of them, right? So we really paid careful attention. We had them under control. They were all in the same room, but they didn't know with whom they were paired up, right? And again, this was experienced managers, just for external validity. So here again, the results from that experiment, what we call, and I'm not really happy with the label, so if you have ideas how to call this thing, I'm very happy to hear them. So what we call unfinishedness or low perceived finishedness. The low perceived finishedness of icon, we did some pre-tests whether people actually perceive a sketchy icon as less finished, and they did. We did some surveys. That significantly raises how people build on each other. So when you make an idea look sketchy, the other is more likely to comment on it and improve it than if you make it look polished. Low perceived finish of an icon significantly raises the ratio of good ideas to total ideas. And the sets of elaborations, how many times you improve an idea, are positively, significantly correlated with the feasibility component of an idea. It doesn't necessarily make it more original, but it makes it more feasible, more implementable, and that's good. You know, it's like reality checking the ideas while you're producing them. So that I think is an important new concept. We don't have a good label for it. I call it signaled unfinishedness or low perceived finishedness. Others call it sort of flexibility. We think we know what the components are. You can see that in this chart. So provisionality is very important, that it signals unfinishedness, that it has this sketchy look. Seamlessness in changing it is very important, that it signals I can be changed, right? I'm not set into stone, that you can do that immediately and the changes are made visible immediately and simultaneously, that different people can do this together. But if you have a good way, what we could call it, this phenomenon that when you make something look provisional, people try harder, then I'd be very happy to hear about that.
Well, Bill Buxton in a book called Sketchy User Interface.
Yes, I'm aware of that.
Right. So he makes the point that the fidelity of an interface should reflect its finishedness.
Mm-hmm. So he also uses the word finishedness, right? And
I'm not certain he uses that word.
Yep. But I think you're right. We cited Buxton in we wrote a book on sketching called Sketching at Work, where we also look at how you can sketch on your iPad and the benefits that come from that. And we used Buxton's work extensively. I think he had very good intuitions. What we try to do is we really try to evaluate it scientifically. So we're looking for this concept that you should signal when you work with visualizations that your thoughts are unfinished, because that provides an invitation to others to build on that. And that's what we want in knowledge integration. But what we see in reality is people use these kinds of tools where even half-baked ideas are made to look polished and convincing. And that's too bad, because it's detrimental to creativity. Right? So I've shared with you 3 key concepts. I've shared with you work in progress about the new key concept that maybe hasn't gotten enough attention, this provisionality or perceived finishedness that should be kept low in any kind of visualization application if you want to engage people. And I also want to just wrap it up by talking a little bit about the applications of this. The motto of my university, the University of St. Gallen, is from insight to impact. So we're trying to do some technology transfer, and some of these tools may actually be useful to you as well. So we have a visual facilitation software that's called Let's Focus. You can download that, and it has about 100 templates like this one. Some of them have law encoding built into them. For example, if you increase the size, if you increase the budget, there's room for less projects, of course. And if you lower the budget level, you have more space for projects, right? That would be a simple law encoding integrated into the interaction constraints of this template. And then there are others, intelligent templates that take some of the laws into account. And it has basically just a number of graphic templates, a lot of them interactive, that managers can use where they can visualize their knowledge in real time. It's basically a facilitation software that came out of our experiments, right? And it's been on the market for about 8 years, and it's doing well, and we just launched the cloud version, and you can use that one for free. So if you're interested, the link is cloudletsfocus.com, cloudletsfocus.com, and you can try that out. It works on any kind of device. It also lets you collaborate. You can send stuff from your iPhone or just any Android phone as well to the sort of the facilitator, and it's really a seamless tool where you can integrate people's knowledge rather than just present to them. So that's one thing I wanted to mention. Let's Focus, our visual facilitation software. Then we have a set of collaboration cards where you can visualize your knowledge through cards. It's a different kind of visualization, more physical. We have a toolbox that you can use online called sketchingatwork.com because we found that a lot of managers, they would like to visualize their ideas, but they have no idea how. Right? And so what we give them in Sketching at Work are just simple models where they can, on a tablet, on a whiteboard, on a flip chart, visualize their knowledge and without being able to draw, basically. And you can check that out. It's called sketchingatwork.com, and we have a number of tools available there. It's a complex one, but also simple ones with short descriptions. And you have a gallery of all the tools. You can download a chapter from the book. And basically it's simple diagrams, visual metaphors, simple ways in which any decision maker or expert can make his or her knowledge more accessible to others. And I'm sure you're aware of some of these, like Ishikawa diagrams, flow charts, empathy map, loop diagrams. Things that signal provisionality, right? They all have low perceived finishness and thus invite others to contribute to it. That's the beauty of this. Then we have a site called Creability where we sort of give you the equivalent tool set but for creativity sessions. Unfortunately, a lot of managers still use what is one of the worst ideation techniques out there, brainstorming. You know, invented in *54, already in '58. The first studies show brainstorming does not work. But in our surveys, we found more than 90% of all managers use only that. And there are great visual alternatives to brainstorming that we have compiled in Creability. And then the demo I showed you is available at diagrams.org. That's this diagram where people can sort of pull in their direction and it affects other people's area of knowledge, so you can see the interfaces in your team. That's at diagrams.org. And another tool that you might want to use, we've put together a little sort of periodic table of visualization methods if you want to get inspired. And the cool thing about them is when you hover over these, you get a sort of a thumbnail representation of what this representation is. It's about 100 of them. You see there, the more it gets complex, the more you go down in this periodic table. The blue ones are process visualizations, the black one are structure visualizations, and you have, of course, a lot of the InfoVis formats like parallel coordinates, but you also have other kinds of visualizations that are more knowledge visualization based, that are more knowledge oriented. And for every format, you have whether it's divergent or convergent, overview-oriented or detail-oriented, process or structure-based, and you have a Wikipedia link to most of them. And that you will find at visualliteracy.org. And then you go to the map section, and you have this, a bit nerdy, I grant you, a periodic table of visualization methods, an homage to Mendeleev, but we wanted to organize all these rich methods of expressing what you know in a systematic manner. And so you have a one-stop shop where you can look for, inspiration, whether you want to visualize your company structure, a complex process, your market, whatever it might be, you can find it at visualliteracy.org, right? Because one problem that we still have in the visualization field is there have been so many great breakthroughs, but few people know about it, right? So this is also maybe a call to action to the students. Visualization is an area where you can differentiate your resume from others. It's not something that your typical computer science major, business major, what have you, has a lot of knowledge or experience in. But changes are happening. The Fortune 500s are all using visual analytics tools now. And if you know about them, that can give you the edge in the recruiting process. And with this, I'd like to come to a conclusion. I hope I've been able to show you that visualizing what people have in their head in a collaborative manner requires really fluid, unfinished, highly interactive methods that don't just show data, but give people richer means of expressing what they know. Not just big data, but also big knowledge, right? But in a way that guides discussions so that the flow of the conversation can be modeled in the creation of a diagram. And that ultimately, this needs to lead to new insights, free rides. For that, you should rely on the entire spectrum of visualization. Sometimes, maybe it's best to just, switch the computer off, move over to the flip chart and have a discussion there, and that's okay. Sometimes, what we found out in one of our studies, you need immersive environments, right? Sometimes it's best that you really have as many dimensions as you can have. And I think we'll maybe see even a comeback of Second Life for some of these applications. So you should really exploit the full spectrum, from diagram, visual metaphor, sketch, 3D, chart, you name it. In terms of implications for designers, I think they really have to pay attention to build visual solutions that offer representational guidance, as Suter said, that take into account the communicative settings. And I know InfoVis researchers are beginning to take note of that it's not always just the individual analyst that's sitting in front of the computer, but groups interacting. And you have to take that into account. You have to make cognitive free rides possible. Managers get scared when it gets overwhelming, so you have to make it easily accessible without great cognitive effort. And you have to let people really also input their own knowledge into these systems and capture what they know. We should not forget about big knowledge in an era of big data. And hopefully, in doing so, you should use the power of unfinishedness, of the power of provisionality, so that people have an incentive to improve what others have said. So don't give in to the temptation to make it look beautiful right away. Make it look ugly. It's good for the process. It lets people try harder. And in that, I think my main message is the process of visualizing is often more important than the ensuing visualization itself. Thank you very much. I'd be happy to take questions or comments. Yes?
So this was very relevant to a project that I'm working in class right now. And the situation is that we are looking for alternative ways to visualize some of the health benefits or negative side effects of medication in order to facilitate collaborative decision makings between doctors and patients.
Yeah.
So for instance, if you have some condition, you're talking to your doctor, and there are several different medications, but this one might have this side effect, or this one might have this,
sure.
This one might have that. And so, can you give me any advice or practical guidance in going through this problem?
First of all, I think that this is a great application area of visualization, empowering patients to make more informed health decisions. And I know that the dialogue between doctors and patients, it needs really help sometimes. We've done a similar study, not in the context of patient and doctor, but financial services advisor and client, where we it was called
I'll get it out.
Yeah, it was published in the Journal of Knowledge Management, but I can give you the reference later on. But what we found is we compared when the expert gave the information on a pre-printed slide, on a computer slide, on a sketch, and by software. And guess what? And we did this many, many times, these 4 conditions. And the patients made the best, or the clients in this case, made the best decisions when the expert was sketching the different options and elements in front of him. When the client was able to, also pencil in his wishes, when it was really collaborative. That was the most effective setting, because otherwise it may be, again, overwhelming information overload. But when you develop step by step, just with a simple piece of paper and pen, these complex ideas, the patient can follow you better, or the client in that case. So I know 2 companies, UBS and HSBCs, they've banned PowerPoint in these advisory sessions, and they're using what they call hand drawing libraries. They're using sketching, because it leads to a much more collaborative atmosphere between the expert and the decision maker, in that case the client or the patient, right? So, but we're also using iPads now, so there's some advantages with iPads. They have the provisionality, or tablets in general. They have the provisionality, the seamlessness, the person. It's very personalized, but you can then add other stuff to it, right? But I think what is essential is don't present it all at once. Develop it step by step. It's again that notion of representational guidance that is key. Increase the complexity step by step. Maybe first the big picture for the patient, and then you go into detail. Like the InfoVis mantra, overview first, detail on demand, right? I think that makes sense for your context as well. Great question, and good luck with the work. Yes.
So, a lot of this goes into team decision making. You've got managers, engineers, product designers. Have you looked any yet at how those teams work together collaboratively like in a conference room that's been outfitted with technology so that anyone at the table can sketch or control what's on the screen? And how does that play out?
Yes, yeah, we've looked at that extensively. And here's a few findings. You know, a lot of people say the new thing in collaboration is design thinking. And I'm a big fan of design thinking, but we've done one study where we compared software and Post-it notes. And what we found was very interesting. When you give people Post-it notes to integrate their knowledge, their main concern is, I want to put my Post-it note on the wall and want everybody to hear about it. And they are less attentive to what other people have to say. It's just about their Post-it notes. And also, people don't read what's on the Post-it notes. They don't build on each other. So I'm not a big fan of Post-it notes. And what we found is, in that case, graphic facilitation with software works much better because it's synchronizing attention. You know, you have sort of a channeling mechanism where the inputs are visualized in real time, right? Like, for example, through Let's Focus, you can take what the person is telling you, you make sure you understand it well, you can change it on the fly, modify it and make sure you understand it well, and then you go to the next person. And so the collaboration with Post-it notes is a bit problematic because you don't get that integration mechanism going, right? It seems...
a technology moderator in the room that runs the visualization for the team meeting.
Yes, yes. We've had very good experience with that because you synchronize attention. You get everybody literally on the same page.
Have you looked at the next step where you enable each person at the table to have direct control of the interface?
Yes, Let's Focus, what I just showed you, and it has that built in.
Okay.
But again, I use it in a mode where that will not immediately be visible to all. I can then, you know, pick one at a time. You can send it with your phone to me at any moment, but then I can sequentially, you know, bring it in. You can position it, and I can make it appear, but it's important to, you know, sequence that. Right? Otherwise, you don't get everybody's attention, and you need attention to build on each other. And then you need persistence.
It's still a room with one conversation, not a room with 10 little conversations around 10 little.
Right, right. And I really believe in the power of this one conversation. Question? Yes, please.
So for the radar visualization that you had where you're creating these dependencies, I know it's getting really specific, but when you're setting these dependencies and whether it's an opposite or same correlation, do you have a way to set the ratio of increasing? So like, because like having one scale go up with the 1-to-1 ratio is completely different than if like the budget goes up 10 times for every 1 time the risk goes up.
Excellent question, and we're working on that. Yes, what we found is managers and decision makers, they don't really know always a lot about, this may be weird for Georgia Tech students, but functions, right? Exponential functions, and so sometimes they have a hard time expressing the nature of the correlation, right? Because it's not just sometimes this goes up, then this goes up dramatically. It can also be this goes up to a certain point, and this too, but after this point, this will go back again, right? So you have these like grow and collapse functions. There's all kinds of functions. And what we found is managers, they know about this, but they have a hard time expressing it. So what we're doing is we're using this tool on big panel screens, and the managers, they can put their fingers, you know, it's multi-touching, and say, look, when this goes up, like I increase the pressure on my work team, performance goes up, but only to a certain point, afterward it goes back down. And so with their fingers, they can encode the knowledge into the diagram, right? Or if they move this just a little bit and this quickly, then the system knows, oh, it's sort of an almost exponential function. But they don't have to verbalize it. They can do their fingers, they can let their fingers do the talking, right? So with their fingers, they can always take two variables together and then show the system how they move together, how they're correlated. So it can be slow, like that this one increases immediately. It can be counter, as you saw. If I increase this, this will decrease. Or it can be it increases for a while, but then it decreases even if that further increases. Does that make sense?
Yeah, that's awesome.
Do I have time for one more quick question? Great, let's thank Mark again.
Thank you.